channel. Today we have solution to differential equation by variable separation. For an equation to be solved by variable separation, the y by x must be equal to f of y, f of x dot f of y. If you can be able to transform a given equation to this form, or the y by the x equals f of x over f of y. If the function of x, all function of x can be separated from all function of y in this form, if it is possible for you to rearrange the given equation to be in this format or this format, then you are good to go by variable separations. So let's see some examples to appreciate this. Example 1. Says solve dy by the x equal to y by x. So how do we go about this? We have the y by the x equal to y over x. So the first thing to do, whenever you are solving variable separation, the first thing to do is to cross multiply. That's the basic. So cross multiply. In cross multiply, we have x dy equal to y dx. So what I want you to understand is when you cross multiply, always ensure that you cross the differential value of y first. So like I crossed x to the y. I didn't do x, I didn't do y dx first. So I have to make sure that I multiply the differential value of y first. So x multiplied by dy is x dy equal to y multiplied by the x is y dx. So if you now want to find out that we have x variable and y variable here, so they are not separated, and y and then the x also. So I need to have all values of x, both differential value of y and x variable or x function, to be together at the same side, and differential value of y and the y function should be at the same side. But if we find out, we see that we have x function with differential value of y, which is not proper, and here we have y function and differential value of x, which is not proper. So how do we separate? Very simple. Take out y here and put it under here. Take out x here and put it under here, so that we have dy over y is equal to dx over x. As you can see now, when I cross multiply, I still have the same thing, so I have not changed the meaning of the question. So now, this value can equally be 1 over y. The y can be written this way, it will be 1 over x. So like this, I can integrate both sides. So integral of 1 over y is lim y. Integral of 1 over y is lim y equal to integral of 1 over x is lim x, then plus, that should be lim c, since we are having all logarithm functions. So we have lim y is equal to, according to the law of logarithm, we take one of the lane and multiply their numbers. We have cx, because addition means multiplication of numbers. So we take out the lane from both sides, y is equal to cx. So this is the solution to the differential equation. Hope you get that very well. Let's get to the second example. The second example says, to solve sin x over 1 plus y dot dy by dx equal to cos x. Okay. This looks quite complex, but we're going to resolve that. Alright. So we have, remember the first thing we normally do is to cross multiply. Whenever you are solving variable separation, always remember that the first thing to do is to cross multiply. So when I cross multiply, you find that this guy can be taken as over 1. Then everything will cross the 1 having differential value of y first. So sine x dy multiplied by 1 will give me sine x dy. Then 1 plus y dx and cos x will multiply now equal to 1 plus y cos x then dx. So that's what we have when we cross multiply. So now what the next thing to do now is we are going to separate the variable. How? 1 plus y in bracket will come down and be the denominator of dy. Y sine x will go and be the denominator. Let's take sine x as the denominator here, and then take out 1 plus y to come as the denominator here. So we have dy over, it's coming here 1 plus y equal to cos x, and sine x coming under here with sine x over sine x dx. So as you can see, sine x multiplied by dy is still sine x dy. 1 plus y multiplied by this is still. So I have changed the meaning point. You can see we are now having the variable separated. So I can equally write this as 1 over 1 plus y dy is equal to cos x over sine x dx. So we can integrate both sides. As you can see, we are integrating this with respect to y. Remember, a differentiation of this denominator is 1, which is the same thing as the numerator. And whenever that happens, we have ln that denominator, and denominator plus c as ln the denominator will be the integral. So the integral of this, check, we will find out that differentiating sine x, differentiating the denominator will give us cos x, which is equally what we have as the numerator. So definitely we have ln that denominator plus, since we have a logarithm function up to be ln c. Okay, so now we have the ln of 1 plus y equal to, of course, according to logarithm, we take one of the ln. Because of addition, we multiply the other contents, which is c sine x. So take down the ln from both sides. We have 1 plus y is equal to c sine x. And then what do we have? Making y the subject, we have y is equal to c sine x plus 1 crossing that is minus 1. And this is the differential equation. That's the solution. Then the next example on the variable solution. Next example on the variable solution. The next example on the variable solution is dy. That's example 3. We have dy over dx is equal to 4y over x into y minus 3. Solution. So make me recap. Dy over dx is equal to 4y over x into y minus 3. So remember, the first thing to do still remains the same. When we cross multiply, we ensure that we cross the one having dy, differential value of dy first. So dy multiplied by this will give us x into y minus 3 dy equal to 4y multiplied by dx is 4y dx. So now we are going to separate the variables now. 4y will come under here, then x will go under here. So taking out 4y and bringing it under here, we have y minus 3 dy, that's over 4y, equal to dx over x. Alright, so if you watch again, you find out that the 4y is having descending denominator, or that's descending denominator, as y is having denominator 4y, 3 is having denominator 4y, so we can separate the values. We can have y over 4y, let's take it gently, minus 3 over 4y is equal to 1 over x, that's dy or dy equal to 1 over x dx. Okay, so y can take away, y can have 1 over 4 minus 3 over 4y. I can say 3 over 4 times 1 over y. Okay, all dy is equal to 1 over x dx. So we can find the derivative of both sides. The integral of both sides. So integral of 1 over 4 is, with respect to y, is that's y over 4, or 1 over 4 y. So you can have 1 over 4 y minus integral of this guy is 3 over 4, integral of 1 over y is ln y, equal to integral of 1 over x is ln x plus ln c. Okay, so with this, I can have 4y minus 3 over 4 ln y is equal to ln cx. So I can take 1 over 4y is equal to ln cx plus 3 over 4 ln y. That's 3 over 4 ln y, and of course I can equally have the LCM multiplied through by 4. So I can have multiply this guy here by 4. 4 will cancel out 4. Multiply through by 4 is y equal to 4 ln cx plus 3 ln y. So that can take 4 up here according to the law of logarithm, so that we have ln cx all raised to the power 4 plus the ln y raised to the power 3. Okay, so going up there we have y equal to ln c raised to the power 4x raised to the power 4 plus ln y raised to the power 3. So taking one of the ln y would be equal to the ln of c, then multiplying the number inside, taking one of the ln and multiplying the number according to the law of logarithm. We have ln c raised to the power 4, x raised to the power 4, y raised to the power 3. Note that ln is the same thing as logarithm to the base of e. Therefore, y is equal to logarithm to the base of e, c raised to the power 4, x raised to the power 4, y raised to the power 3. Then according to the definition of logarithm, this logarithm is defined by exponential y equal to exponential y equal to c raised to the power 4, x raised to the power 4, y raised to the power. We can say let c raised to the power 4 equal to a, so that so that y is equal to a x raised to the power 4, y raised to the power 3. And then this will now serve as the final answer. Example 4, we have x squared plus 1 dy by dx equal to xy. Okay, so the first thing we do at all time is to cross multiply. So we have x squared plus 1 dy over dx equal to xy. When we cross multiply, we have, of course, x squared plus 1 dy, and this is like over 1 multiplied by everything here is repeated, and this is equal to xy dx. That's a dx multiplied by xy. We have that. So how do we separate the variable? X is already here with dx, so I'm going to take y from here and put it under here, and an x squared plus 1 and take it under here. So that I have dy over y is equal to x over x squared plus 1 dx. So that's what we have there. We integrate both sides, but before then, with 1 over y, dy is equal to x over x squared plus 1 dx. So integrating both sides, we have ln y is equal to, then integrating here, of course, to give us 1 over 2 ln x squared plus 1 plus ln c. And of course, what we have 1 over 2 is the differentiating here is 2x, and then what we have here is x. So because of that too, instead of having ln the denominator plus c, the formula changed and it becomes 1 over 2, then ln a, because of the 2 and the denominator, we have that 1 over 2 ln the denominator plus c. So if I have integral of x over 3x plus 4 dx, differentiating this denominator is 3. Okay, let's say that's not the perfect example. What I want to say 4x squared, let's say 4x squared, yeah. So differentiating this will give me 8x. While what I have here is only x. So the answer to this under integration is 1 over 8 ln 4x squared plus 4. That is the answer. Okay. So we have that. So we have ln y equal to 1 over 2. Okay. We take the 1 over 2 up there. We have the ln of x squared plus 1 raised to the power half plus the ln of c. Then taking one of the logarithm, we have the ln of y to be equal to the ln of c multiplied by x squared plus 1 raised to the power half. So when ln cancels ln, y becomes c of x squared plus 1 raised to the power half, which we can water down to c multiplied by the square root of x squared plus 1. So that eventually becomes the final answer. Then the last example we're going to look into now, that's the last example. That's example number 5 before we close it for variable separation. Example 5, express the variable separation. Example 5. We have x dy over the x y plus xy. Okay, by variable separation we have x dy over x is equal to factorize y into 1 plus x. Okay, that's by factorization. So I have, now I can cross multiply. So I have factor this now. You can see the function of x here and function of x here is kind of being separated now. So here I'm going to have, by cross multiplication, we have x dy is equal to dx. By that it's y into 1 plus x dx. So that, so separate the variable, take y down here, we have 1 over y dy is equal to 1 plus x over x dx. So which we can still write as 1 over y dy is equal to 1 over x plus, and then x divided by x is 1, then all dx. So by integral of both sides, integrating both sides, we form ln y is equal to ln x plus x. Its integration of 1 is x, then plus c, right? Plus c, so that I can have ln y minus ln x is equal to x plus c. So I shouldn't have ln c because at the b we have all logarithm function all through. We should have written plus c, but because we have ordinary function of x here, so we have plus c and not ln c in this very question. So now watch here. Alright, we can have ln, because of minus is division, y over x is equal to x plus c. Y over x is equal to x plus c, so that I can have y over x is equal to exponential x plus c by applying exponential. That's so. If I have to be more clear, I will say logarithm to the base of e y over x is equal to x plus c. From what I have stated before now, the ln is something as log to the base of e, so e exponential x plus c must be equal to, that's y over x must be equal to exponential x plus c. Finally, y is equal to x, by that is x exponential x plus c. Can anybody say y equal to x exponential x dot exponential c? So that when e is common, you can get to this level. So with this, one can say let exponential c equal to a, so that y will be equal to x into exponential x dot a. Finally, y will be equal to a x exponential x as the final answer.